The last of the processes that we're going to look at is what's called an adiabatic process. So let's take a look at the English again. So A means not or no, and then dia again means way. So there's no way for the heat to flow. So in this situation, Q equals 0. No heat flows. There's no heat flowing in the process through the wall. So you either do that with an adiabatic wall, such as styrofoam or something like that, or you do it very quickly. So there's no time. So my delta T approaches 0. So I do it very, very quickly, and there's not enough time for the heat to flow into my system. So let's take a look at what that would look like. So I'm going to move. Here's my PV diagram, and I've got 3 isotherms drawn on it. Here's this one's at PV, this one's at T naught, this one's at 2 T naught, and then this one's at 4 T naught. So what I'm going to do is the amount of work, the change in energy is going to be the amount of work that's done on that system. But change in energy is also NR delta T. I'm sorry, 3 halves, there we go. 3 halves NR delta T is the total amount of energy. That's how much work is there. So 3 halves NR delta T is going to equal how much work is done. But notice that's also negative P delta V. So as T goes up, my delta V goes down. As my delta T goes down, this is going to go up. So if this is negative, this one's positive, and if this one's positive, this one's negative. So here we go. Kind of. This is, I should have put this D out. All right, so this is negative delta PV. So this whole thing is going to be there. So let's take a look at what's happening here. So I'm going to start here on some isotherm. I'll start at 2 P naught V naught, and I need to go adiabatically. So when let's expand adiabatically first. So I'm going to go down to here. This is what would be known as an adiabatic expansion. Adiabatic expansion. All right. Expansion. How do I know this curve is adiabatic? I tell you. Right? If I don't tell you, you don't know that. So then how much work is being done? What's the area under the curve here? What's this work? Well, if we go back over here, we can just look at it's 3 halves NR delta T. All right. Now I can undergo an adiabatic contraction as well, so I can start, maybe if I can start here and I can work my way up to here, so I can go this way on that one. So again, how much work is required, how much work happens here, we can measure it there. But when you have adiabatic expansion, the only way you can change the energy is by doing work on the system or having the work be due on the gas. The system doing on the surroundings or the surroundings on the system. There's got to be work there. No heat is transferred.